Good afternoon, everyone. My name is Chandraprakash. I am an assistant professor in mechanical engineering at IIT Kanpur. I would like to showcase some of the work that we have done or we have been doing, and also list out a few projects that we have been doing. So I've also listed my phone number. So feel free to call me and meet me to discuss more on this. So there are about 3 to 4 areas that the lab has been making good progress in. One of the first things that we have been doing is on filtering what is called as a sound pollution, or also called as acoustic noise. Okay, you do not need an introduction on where this noise is coming. It's coming from aircrafts, it's coming from vehicles, it's coming from industrial machinery, or also from the loudspeakers on the roads. Right? There are two ways in which people do this. One is metamaterials and other is materials. So I'll try to show what are all the problems that we have been solving. The first thing is, you all heard of Doppler effect, which is, when you have a moving sound source, or when the receiver is moving and in the presence of a sound field, then you see that you do notice that there's a shift in frequency and so on. Now we do something very similar, where there is a speaker and there is wind. The wind could be going along a particular direction, or it could be a swirling circular motion kind of thing. And we would like to see how the sound is perceived, how is the propagation being altered. Okay, so what we're going to do is, we're going to examine how the sound is going to propagate and attenuate in the presence of a fan. I am speaking and there's a fan next to me. You will hear it differently, or the person in front of me, or the person sitting at 60 degrees with respect to the normal, he's going to hear it in a different way. So that is what we're going to explain. It involves very standard acoustics, and the work will involve largely programming and basic acoustics, which is there. So it's a very simple problem, worth trying it as a part of a PhD program, PhD thesis, or a significant part of an MTech thesis. That's the first one. These days, there are these sound absorbing or noise insulation materials which are being made of petroleum. For example, the sponges inside the couch or the sofa they also absorb sound. Just that they are made of petroleum. They are made from petroleum byproducts. We would like to make use of what are called as biodegradable materials, which when I put it in the soil, they just degrade and they just become part of the soil. So we have been using agricultural waste to make these kinds of foams, and which have been quite good in absorbing sound. So the next material that we have in mind is Kena, which actually looks like cotton. Okay, we have the material. We also have the procedure to make those foams. We also have the instrument that can measure the properties. And of course, we don't do blind measurements. We will be explaining as part of it, right? Likewise, the parallel project that we have is, given a fluid, if we are able to measure bulk modulus as a function of frequency, the idea is to predict bulk viscosity also using the same data. So if you measure one, you don't need to measure the other one. Okay, or if you measure the second one, you don't need to measure the first one. So this is something which we have already made some strides. So the work may largely revolve around programming and a bit of experiments. So again, these are all small. I'm listing small topics such that you can pick and choose a specific problem which is interesting you. And the other thing which the lab has been doing is, I'm not going to detail very much here. So what you see is a bunch of periodic, one-dimensional, two-dimensional, and three-dimensionally arranged periodic materials. The waves or the sound, or think of the sound or the elastic waves that propagate through them, have specific characteristics. Okay, I will not delve deep into it, but those of you interested can look up on what are called as phononic crystals. So here we like to do some kind of an inverse problem. So this topic will largely be on programming. Okay, so this is roughly the set of 4 to 5 problems in acoustic materials or metamaterials. The second line of work that we do is in thermography, or thermal non-destructive evaluation. As some of you may notice, these are not the usual images. These are taken by what is called as from a thermal camera. The red regions indicate that they are thermally hot, and the blue or the purple regions indicate that they are relatively cooler. Okay, we do have one such camera. And we've done some basic experiments. I'm trying to show what, based on what you know. So this is a standard tensile test, right? A typical stress strain curve. At the same time, using an infrared or basically a non-contact thermometer, if you are able to monitor the surface temperature, you will see that the temperature will slightly drop and slightly glow, and it will go up. And this happens all the time. Okay. One such explanation is something which we have done, and the elastic regime why it reduces and plastic regime why it heats up. Likewise, we have done something similar for the fatigue, and we were able to use some basic phenomenological models, and we were able to explain, right? So that's done. So like then we are into springs. We've done something called what is called as the wire ropes, which is basically nothing but these heavy duty cables which are used in dams, cranes, or even the electrical wires. We have done such advanced experiment. Now we want to do something simple. Take the springs which you see on the screen, and we're going to do some basic tension, twisting, fatigue kinds of experiments. All of these experiments can be done on a table, okay? A simple table in an office. And we measure the temperature and we'll explain using very simple basic mathematics and some preliminary programming. Okay, this could be a, again, this is again a topic. It can be swung either way, either through experiments or programming, and it fits equally into MTech and PhD. And another project which is of interest to many labs and even industries is you see the wall in front of you, you see the floor, you see the desk, you see the door. Can I measure the thermal properties like thermal conductivity, specific heat capacity, coefficient of thermal expansion without actually cutting that material and taking it to a lab and use it on a specific equipment? We don't want to cut it. We want to measure it on the spot. So the way we do is we do give it some heat. We measure using thermal camera. We acquire the data, and either you do the traditional optimization using analytical methods, or you're welcome to jump into this artificial intelligence based methods. Okay. Either way, there's scope to work through this problem. Okay. Likewise, we've had some success using our classical instruments which we carry them all around, the smartphones. The cameras are too good, and what we have used is, the in the pictures that you see, the droplet on a fabric, on a car, on a windshield, and also on a leaf. Okay, the idea is to measure the contact angle on these materials. Okay, on a car, if I want to measure, I don't want to cut the portion of a car and take it to a lab. I want to measure it on the spot. So one of the previous students, what he did is, this is how you do it on a commercial instrument. One of my previous students, we purchased a smartphone. We purchased a small lens, which is about, I think, 1500 rupees. And the left hand side is what we were able to predict using deep learning. The right hand side is what you measured conventional. So we had a reasonable accuracy. Now we have done it on flat substrates. We want to do it on curved surfaces. Okay, that is the problem here. And this problem involves, you should be inclined to do a lot of programming, whether you want to do deep learning or you want to do a physics based approach, but your interest should be inclined to do a lot of programming. And the other thing which we had success was in soft robots. Please visit my website. Okay, it's from the mechanical engineering faculty. There's a link to personal homepage. On the front page, there is a video of about 4 minutes. Please visit that, and then if you're interested, we can continue on discussing this one. So largely, now the lab has about 3 kinds of functional equipment. One more is being built, and we also have computers and programs and the standard softwares which one would like to use. And the work so far to date has been catered towards fundamental problems, applied problems. Okay. And there is always a freedom to choose what kind of problem you want to work, whether it is fundamental or applied, or you want to do a combination of theory and computation, theory and experiments, computation and experiments. Either way is fine. Okay. The good part is, so far to date, all my students have been placed. Okay. So that is the lab had the students who worked in the lab have done fantastic job. That I will definitely say, and all of them got placed in those companies or labs where they wanted to get placed. So on the front page is I listed my phone number. I think I just finished my 10-minute quota. Please feel free to call me and express your interest, or if you are not sure, you want to know more about a specific topic or on what you would like to work with, please give me a call or write me an email. All right. Thank you very much.